This is standard 8GB7. We're going to apply the Pythagorean theorem to determine unknown side lengths in right triangles. Now remember, you can only use Pythagorean theorem in right triangles. In our case, we're going to do this in real world and mathematical problems and in 2- and 3-dimensional figures. So let's start by remembering the names that you'd have for pieces of a triangle. Now, let's grab our pen. And if I've got a right triangle, I'm going to have a right angle. See the right angle right here? It's a 90-degree angle. The sides on a right triangle, the two short sides, are going to be called legs. Doesn't matter which one is which. They're both legs. The long leg on a right triangle, the one that is across from the right angle, is called the hypotenuse. Hypotenuse. That's the long leg. Now, if we want to remember what Pythagorean theorem actually does, it allows us to find the side lengths in a right triangle. If I'm talking about a right triangle, the hypotenuse, the side that is across from the right angle, is C, and the other two sides are called A and B. The two legs are called A and B. It doesn't matter which one is which. Pythagorean theorem goes like this: A squared plus B squared is equal to C squared. And when I'm missing one of those, I can solve for the one that I'm missing. If I've got two of the side lengths, I can find the third. Now, let's start with this. We're going to find the hypotenuse length in this right triangle. Notice in this one, we've got the two legs. We're looking for the hypotenuse, the side that's across from the right angle. Just as we said here, when we're labeling these, C is the side that's across from the right angle. It's the long one. It doesn't matter which one is A and which one is B, but C is across from the right angle. If I'm finding C, I'd use Pythagorean theorem because it's a right triangle. A squared plus B squared is equal to C squared. And now I substitute in what I have to find what I don't have. I don't have the C, so I'd substitute in the A. In this case, I've labeled A as 5, so I'm going to substitute 5 in for A. That's 5 squared. I'm going to substitute 12 in for B. So that's 12 squared is equal to, notice we don't have C, that's what we're looking for, is equal to C squared. Now let's just do the math. 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, which is 144. And that would give me C squared. Now if I add these two together, I have 169 is equal to C squared. Now look, we're not looking for C squared, we're looking for C. This says C squared. How do I get to C if I've got C squared? The opposite of squaring something is to take the square root. And if we're going to do that, if we're going to take the square root on one side of the equal sign, we have to do it on the other side. The square root of C squared is C. The square root of 169 is 13. So this side is 13. We know that the hypotenuse is always the longest side. Let's look to see what we have. 5, 12, 13. That makes sense. That could be the length of that side. Now, let's find a leg length. Find a leg length in the right triangle. That was the hypotenuse we just did. Now we're going to do one of the legs. If you go back and look at it, we talked about it. The leg is one of the sides. It's not the hypotenuse. Okay, the hypotenuse is the long side across from the right angle. A 25-foot ladder, that's going to be important to us, looks like, leans against a building. The base of the ladder is 10 feet from the base of the building, okay? So that looks like that's going to be important to us. Determine how far up the building the top of the ladder will reach to the nearest tenth of a foot. Okay, I've underlined those things I thought would be important. First off, it's important to draw a diagram so we know what's going on. We've got a 25-foot ladder that leans against a building. I'm going to sketch a building here. So if we've got a building, here's building, there's the ground. I'm going to put in some windows. You know it's a building. See? Windows. All right. Now, we have a ladder. and it goes up to the top of the building. I'm going to put some rungs here so you'll know that this part is the ladder, and that's the ground. And we know that the building should be at a 90-degree angle to the ground. So what we're looking at here, let me put a different color so you can see this. What we're looking at here is a right triangle. See? I'm drawing it off in blue so you can see it. We've got a right triangle right there. We need to, this is the right triangle, we need to put in what we've got, a 25-foot ladder. Well, here's our ladder. It says it's 25 feet, so we're going to put that there. The base of the ladder, here's your base of the ladder, is 10 feet from the base of the building. There's your base of the building. Base of the ladder, base of the building, it says that's 10 feet. Determine how far up the building, this is how far up the building, the top of the ladder will reach to the nearest tenth of a foot. So I'm looking for this height, right? I could call it any letter I want to. Let's look at the triangle we have. It's a right triangle. We're trying to find the length of one side of the right triangle. So we're going to need to use Pythagorean Theorem. A squared plus b squared is equal to c squared. So we can find a missing side length in the right triangle. We know C is always across from the right angle. So this side is C. It's the longest side across from the right angle. It doesn't matter which one is A and B. Now let's substitute. I've said A is H, so I'm going to substitute H in for A. B is 10, so I'm going to substitute 10 in for B. C is 25. I'm going to substitute 25 in for C. Now let's just simply solve for H. Let's leave H squared alone. 10 squared is 100. 25 squared, see what 25 squared is? Use your calculator. 25 times itself is 625. Now we're trying to solve for H. We need to cross the equal sign. We need to get rid of the 100. It's added here. To do the opposite is to subtract 100. And what I do to one side, I do to the other. I now have H squared is equal to 625 minus 100 is 525. But I'm not looking for H squared. I'm looking for H. This has H squared. The opposite of squaring something is to take the square root. So on each side, I'm going to take the square root. If I take the square root of H squared, it's just simply H. Now, in your calculator, if you've got a TI-30X2S, you would put in second function, square root, 525 equals, and it will give you 22.9128. Let's see, it gave me 22.9128, well, 9, but it says it only wants us to the nearest tenth of a foot. Tenth means one decimal place. Remember the old saying, so we're looking at this one decimal place. Remember the old saying, 5 or more, raise the score, 4 or less, let it rest. So we look at the number behind this. That's 4 or less, it's 1. So we let it rest. We don't change the 9. We leave it like it is. Our height then is 22.9. And what's our units? What are we talking about? Feet, right? 22.9 feet. Now let's put that over here and see if that makes sense. We said 22.9 feet. Okay. We said the long side's 25. The two shorter sides are 10 and 22.9. Okay. So the longest side is indeed 25. These two are shorter. That would make sense. Now let's look at a three-dimensional figure. What are we doing Pythagorean theorem when we've got 3 dimensions? When you're dealing with Pythagorean theorem in 3 dimensions, and we're looking for a diagonal in a box, this is called a rectangular prism because you've got all the sides here basically are opposite each other. You've got a top and a bottom that are congruent. This is a rectangular prism. We're looking for the length of the diagonal. See how this is this is from the back side corner, and this is the front side corner. So this is a diagonal. It's not just on one plane. It's using the 3 dimensions of the box. It's like putting a bat into a box and the top part of the bat is here in this back corner, and the bottom part of the bat is in the front corner. If a rectangular prism has length, width, and height, and a diagonal, then the following formula is what you use to find the length of the diagonal. Length squared times width squared times height squared equals diagonal squared. Now that looks a lot like our Pythagorean theorem. A squared plus b squared is equal to c squared. What we're doing here is when it's 3 dimensions, we just add one more dimension here, right? When it's 2 dimensions, we have 2 different sides. When it's 3 dimensions, we have 3 sides to find our diagonal. Okay, so let's try an example. Chip wants to ship a steel rod in the box shown. Chip wants to ship a steel rod in the box shown. The length of the longest rod that will fit into the box is shown as the segment D below. See, it goes from the back corner at the top to the front corner at the bottom. This D does. What is the length of the longest steel rod that he can ship in the box to the nearest tenth? Again, we're going to a tenth of an inch. Well, if we're dealing with 3-dimensional figure and we're looking for the diagonal, then we do it this way. Length squared plus width squared plus height squared is equal to the diagonal squared. Now we simply plug in our pieces here, substitute in. The length is 20 inches. We will substitute 20 in for length. The width of the box is 6 inches. We're going to substitute 6 in for width. The height of the box is 6 inches, so we're going to substitute 6 in for height. And that's going to give us our diagonal square. 20 squared. In your calculator, put in 20 squared. And 20 squared would give you 400. Okay? So let's substitute 400 in place of 20 squared. 6 squared is 36. Let's substitute 36 in place for 6 squared. 6 squared again is 36. Let's substitute 36 in place of 6 squared. And that will give me D squared. Now let's add these up. 400 plus 36 plus 36. And that would give you 472. We would substitute 472 for 400 plus 36 plus 36. And that's equal to D squared, but we're not looking for D squared. We're looking for D. To get to D, when you've got D squared, you would take the square root. What you do to one side of the equal sign, you do to both sides. So I need the square root of 472. In your calculator, again, if you have a TI-30X2S, you would put in second function, square root, 472 equals, and that would give you 21.726. But, again, it says we want to the nearest tenth. So let's make sure we do this to the nearest tenth. We find our tenth space. We look behind it. 4 or less, let it rest. 5 or more, raise the score. This is less than 5. This is 4 or less, so we don't change what's here. Our diagonal would be 21.7 inches long. Now let's see if that makes sense. 21.7. This side is 6. This side is 6. That's 20. This is going to be the longest length. 21.7. That would make sense. And that goes over how to handle 2-dimensional and 3-dimensional Pythagorean theorem problems, finding the side lengths in right triangles. That's good.